Hey guys, my name is Solbyte, and today we're going to be going over object-oriented programming. Object-oriented programming is basically just a style of programming that allows us to utilize objects in order to make some of our tasks a lot easier. And you can think of an object as kind of like an entity that bundles certain data and functions. If you're a little confused, don't worry. When I first heard what an object was, I was quite confused too, but I learned better with examples, so we will go over an example today by creating a user class. And before we get into that, I want to kind of bring up why we would use an object and kind of, what it could help with. So for example, if we were creating a website that had users and we had users sign up the website and fill out information like their name, age, occupation, etc. It would be good to have something that would store all of this data for each specific user, right? So for each user, it would have their specific age, their specific name, their job, etc. So we can do this by every time a user signs up, we create a new object, a user object, and this user object will hold the name, age, and occupation of the user, and that way it's kind of all just in one place and neatly organized for each individual user. And the way that these objects will be created is using a class. Now, a class you can think of basically as a blueprint for creating an object. So a class will allow us to define which data, which attributes, which members of that object will be in each object that is created. So hopefully that kind of makes sense. If it doesn't, don't worry. Object-oriented programming is one of those first hurdles that you kind of have to get over in computer science. So just keep sticking with me, and I'm going to show you guys kind of an example of a class here and how we can use that to create an object and even access the data with each individual object. So we're going to start by creating a class, which, like I said, is like the blueprint, and we're going to name it user. So this will be the blueprint for each user object that is created. Now, very important, something that is very specific to classes and structs is that we need to add a semicolon here. As you can see, the next line gets a red line. If you don't, it's something that's kind of specific to things like classes and structs. So just, pretty important. If you're not using an IDE like VS Code, that can kind of tell you that. So just kind of make sure to remember that going forward. Anyways, so we're going to go ahead and create a blueprint for each object. So for each object, for each user, I want them to have, or I want to store the information of, let's say, their name, and let's just do their age. Let's just do name and age for right now. So these are the members of this class. The members, a member of a class is basically just like the things that are stored inside of each object, the thing that is accessible for each object, basically. So the name and the age are members of the user object, the user class. So now let's go ahead and kind of show an example of how we would exactly create a new user. So this is pretty simple, actually. I'm sure you guys have seen something like this, creating just a number variable, right? So creating a new user object is done in a very similar way. We just define the data type, or the object that we are trying to create here, that being a new user object. And then we're going to go ahead and name it user1. And now we have an object named user1. So user1 now has these two attributes inside of it. However, right now it's null because I didn't predefine it, and we haven't used any constructors, which I'll go over constructors in my next video, but for right now, it has nothing inside of it. So how can we access these members inside of the user1 object? So the way that we can do this is we can type user1, so the name of the object, dot, and then access whatever we want to access. So let's say the name, right? But hold on, we have a red line here. This is because we're running into a problem with the scope of these members. So classes have something called access modifiers, and there's 3 of them. There's going to be private, public, and protected. I'm not going to go into protected today. I'm going to save that for a later video. But for right now, the more important ones are going to be private and public. So what's the difference between those? What does that mean? What am I talking about? So basically, these things identify where these members can be accessed in program. So by default, if nothing is specified about these members, they are automatically private. So that means that we cannot access these members. We can't change their values or anything like that outside of the class declaration here. So that means we can't change the name to, say, Solbyte. We can't do this. However, we could very easily do this inside of the class declaration itself. So, because it is a private member. So then we get into the public access modifier, which allows us to access and change the members of an object from basically anywhere inside the code. So I'll go ahead and show an example of how we would identify this, how we would modify it to so that way these members can be accessed inside of the main function here. So all we have to do, it's pretty simple, just write public and then use a colon. And so now anything after this colon here, any member after this colon will be public. So as you can see, the red line here has disappeared, and that is because we can now change user1's name to Solbyte. So these are now public. I'll go ahead and show a little, a little example of how we can do a private member, because you can do public and private, and there's good reasons to do both. If you want certain data to be hidden from the rest of the code, you don't want it to be accessed, you don't want it to be modified, etc. So let's say something like an ID, I guess, right? So like the ID of a user could be private. So if I try to go here and identify that, or access that, we obviously can't. And you can actually see, if you're using an IDE like VS Code, you can actually see which members you can. Okay, that's because I just put it there. Okay, I was confused. I was like, what? But yeah, you can actually see which members you can access and modify here in this little drop-down menu, and that is if you're using VS Code like I am. So anyways, let's go ahead and actually fill user1 really quick. Let's kind of give it the correct attributes. So I've already changed its name. Let's go ahead and change the age. And yeah, that should be good. So now let's go ahead and print this to the terminal, just so that way we can kind of see that these attributes for our user here has actually been updated. And sorry, I'm having to look behind a pretty big microphone right now in order to see certain things. Okay. Perfect. So we're going to have this print to the terminal really quick. So let's go ahead and open up the terminal. And let's see. Compile, and let's go ahead and run it. And as we can see, the name Solbyte and age 22. Perfect. That is exactly what we want to see. All right, so hopefully this is making sense so far. One more thing I do want to kind of show you guys that is very handy is, let's say we don't want this functionality here in the main function. We want the main function to be as clean as possible, obviously. So let's actually use something called a class method. And a class method is essentially just a function inside of the class. So it's a function that you can use on an object. And here I'll kind of give a little example of that with the print information. So we'll create a function, print info, and let's just kind of do the same thing here. I think would be the best example that I can show. And one thing is we can cut out the user1, so we can just use name and age because it's accessible from right up here. So now what we can do is, instead of writing all of this here in the main function, we now have this method that can be called for each user object. So we're going to go here to user1, and as you can see in this little drop down menu, the print info is available because it is a public method. Let's go ahead and do that, and let's go ahead and recompile one more time, and as you can see, the code still works perfectly. Prints the name and the age. So that's a pretty basic introduction to classes and object-oriented programming. It's actually really cool stuff. It makes programming a lot easier for really big projects, really big data types that may have specific functionalities within them. So in my next video, I'm going to go over constructors and how we can use those to create a new object with predefined values. Because let's say if I go down here and I just let's say I just totally comment out, just for an example, I just totally comment out these, me changing the attributes of our user1 object. So let's go ahead and just kind of see what happens. And as you can see, we're getting what looks like to be some memory overflow and a blank string. So obviously we don't want something like this to happen. So this is why constructors are very important for creating new objects, and I will go into that in my next video. So with that being said, thank you so much for watching. If you guys have any questions, or correct me if you want as well, I guess. Let me know down in the comments. And with that being said, thanks for watching. Where we are going to go over the basics of object-oriented programming with classes and etc. So today we're going to be going over constructors. So first, I want to kind of recap a little bit one of my last points in my last video, that being what happens if we don't assign anything to this user1 object here. What would happen if we just created the object and then printed the information of that object? What exactly would it print? So we're going to go ahead and compile this and then run it. And here we can see we get name blank and age 2. So clearly this is, I didn't specify age 2 anywhere here. So clearly we don't exactly want this kind of thing to happen. And what we're seeing here is actually something from the compiler. So if you don't create a default constructor, which I'll go over here in just a second, then the compiler actually has a default constructor and assigns the values however it sees. And so it can be kind of random at times. It can have a lot to do with specific values and whatever specific memory address this object is in. And you can get random values like, for instance, age 2. So, but this is a product of the default constructor that is automatically built for each object of a class. And it is dictated by your compiler. So, but obviously we don't exactly wish for this to happen, especially if you want to, let's say, create an object before getting the information of what is going to be, the attributes of that object. Like what is, whenever a user is created, maybe we want to create the user and then allow the user to actually fill in these attributes here, like it's like their name and their age. So when it comes to the actual definition of a constructor is basically just a method that builds the object with the attributes that you want it to, if that makes sense. You can kind of think of a constructor as like the builder of an object, the same way that I said that a class is basically the blueprint for creating an object. You could think of the constructor as the builder, and that builder is in the form of a method. So let's go ahead and actually create one, and before that I want to bring up two pretty important facts about a constructor. One, unlike other methods which will have a return type, a constructor does not have a return type. So that's just one kind of unique thing about constructors. They will not need a return type for whatever reason. And the second fact is that the constructor will have the name of the actual class. So for instance, the constructor name will just be user. And just like that, we've built a constructor. This is our new constructor. Right now, this is actually in the form of a default constructor because there are no values here, but let's just make a normal constructor that will build the object with the correct values. So let's say that we want to pass in the values to assign to the user's name and the user's age. So let's put string name and int age. So now I'm going to assign the name. In fact, actually, I kind of messed this up here. Sorry about that. These need to be different variable names compared to the actual attributes name of the user class. This is because we're going to be assigning the actual value, the actual attribute that's in the object, to whatever parameter we want to pass into this constructor. So very important. Sorry about that little mistake there, but we'll do that for both of these. And just like that, we've built a constructor. So how do we actually see this now? How do we go about this? So as you can see, there's actually now a red line here indicating an error, and it says that no default constructor exists for class user. And that is because we already created a constructor, the compiler will no longer use its own default constructor. So how do we actually, use this now? How do we use this constructor to build our object? So what we'll do is we'll set it equal to the constructor, and then we will pass in some values. So the first parameter is the name, and the second is going to be the age. So let's pass in Solbyte and then do 22. All right, perfect. So now whenever we run this program and use the print info method that we have defined in the class, we should be able to see the correct information. Just like that, we do. So perfect. So this is just a normal constructor, but I want to show what happens if we just kind of want to keep it like this. What if, for whatever reason in your code, you don't want to, wait until you have all of the information about what will be in that object, what attributes the object might have, and then make it? What if you want to make the object first and then allow values to be put in later through the form of like a mutator method, which we'll get into in a later video, the different types of methods like accessors and mutators. So, but for now, let's just say that we want to just create a object with default values. So we'll create what is called a default constructor, different from like a normal constructor. So let's go ahead and do that. So we'll just have it basically have no values, no parameters here, and we will just fill in what we want the values to be by default if nothing is defined. So let's just put the name as NA, and we will make the age -1. Perfect. So now the red line has disappeared, and let's go ahead and check, because now we're using the default constructor. We haven't, passed in any parameters, nothing like that. So this user1 should now have these values by default. So let's go ahead and try to run this and just kind of see what we can see here. Look at that. Name, NA, and age -1. So yeah, constructors are very handy, and they can look a lot more complicated with the more, however many attributes you have. And they're a really nifty way to avoid any sort of weird memory overflow errors that could come about from using the default constructor from the compiler. So constructors are very handy for whenever maybe you just want to create the object before putting any values into it, or if you want to create the object and properly put in the correct attributes based on either user input or just whatever attributes or parameters you want to pass into it. So anyways, with that being said, next video I plan to go over encapsulation, and yeah, if you guys have any questions or other comments, please let me know in the comments down below. And yeah, thank you for watching. Hey guys, it's Solbyte, and today I'm going to be going over encapsulation in object-oriented programming, or in classes. So encapsulation is a way of defining our classes where we make these members, these attributes here, this data, inaccessible from outside of the class itself. This is for the reasons of like data integrity, consistency, security. There's many different reasons to do this. A lot of complexity can be avoided as well. It makes the code a little bit more readable. It makes bugs easier to kind of find. And, overall, there is just a multitude of different reasons why encapsulation exists. So what exactly is encapsulation? So, or I guess what is more so like, how do we do it? So the thing that we're going to do is we are going to make these members of the user class private, and then we're going to add two different methods that allow us, two different methods for each member that will allow us to access the value of the member, and one to mutate the value of the member. So let's go ahead and kind of show that really quickly. So in case you guys forgot, I'm using an access modifier here, private. This will make it where our name and age variables will be hidden outside of the class. So I'll show a little example here really quick. So as you can see, if I go down here to the main function and I try to, I just try to get the name of user1, get a red line because the name member is inaccessible. So, however, if you have a keen eye, you can tell, or you can see that here in the printInfo method, we are definitely able to access the name. That is because obviously, we are in the class. This is the class, sort of definition where we are defining the methods and members of the class. So the method can access the info. So even if we actually have these values private, I can actually show you guys, if we go to the terminal here, I can show you guys that we can very clearly still see these members, even if the values are now private. So as you can see, we get NA and -1. That's because we're using the default constructor, which I went over in my last video, if you guys want to go check that out. So we can still see these values despite them being private. So that's a very good thing because this allows us to kind of be able to hide the values directly in the object, but still be able to access the values and modify them using the accessor and mutator methods. So let's go ahead and show some examples of these. So first we'll do the accessor method, which I do want to kind of go ahead and fix this. These are more commonly referred to as getter and setter methods. My professor always called them accessor and mutator, so I've always kind of called them that, but I think this is the more common phrasing for these types of methods, so I'm going to try to stick to getter and setter. So let's go ahead and create a getter method for, let's say, name. Let's do the name. So we'll do, let's see, we want to return a string because we are getting the name of the object. So let's do the return type string, and then we'll do get name. So this will be a method that will allow us to access the name, and we'll simply just do return name. So this method will now return whatever the name value is here in private. So let's go ahead and just kind of show a little example of that really quick. We'll go down here to user one, and as you can see, get name is public. We can access it, we can use it. So this will now return the name. So if we wanted to, just a little quick example, if we wanted to do, if we just wanted to print the name of our user one, we can just kind of use something like this. I'm going to comment out this, that way it's a little bit more readable whenever we compile this here. So let me go ahead and compile this. I guess I can just do this. Nope, not that. There we go. So yeah, now if I just go ahead and execute that, we get the name. So perfect. We can still access the name of the user one object without actually directly accessing that value. So that's very good. That's very good for, ensuring that data is protected and consistent as well. So let's go ahead and do a setter method now. This one will be a void because we don't really need to return anything. We're just modifying the name instead of returning it. So we'll just go ahead and do set name, and then we need to define what parameter we want to change the name to. So let's just do string name, same thing we did here in the constructor, and then we will set the name member to the parameter name. So now let's go ahead and do user one set name, and right now it's NA, so let's go ahead and change it to my name, and let's go ahead and run this code and see what we can get from it. As we can see, Solbyte pops up. It's perfect. All right, perfect. And of course, usually we want to create a getter and a setter for all of our members. I mean, there will be some instances where maybe you wouldn't want to do that, but here we will kind of do something very similar. That way we can be able to see the age as well. So let's go ahead and do int get age, and we'll just kind of do the exact same thing. And then down here, let's go ahead and create a setter for the age as well. That way we can change the age to whatever value we would like to. So let's do age equals the parameter age. And now down here, let's go ahead and copy this, and we'll do get age instead. And let's go ahead and change the age to, let's see, how old do I want to be? Let's say I want to be 99 years old. Let's do that. So now let's go ahead and run this code and see what we can get from it. And Solbyte 99. Perfect. All right, so that's a very basic run through of encapsulation. Like I said, it's a very handy feature and something that is really good for readability, data integrity, security. It's better to not allow anything outside of the class to be able to directly access these values. We don't want any weird consequences happening from some weird, functionality later on in the project. So it's usually a very good rule of thumb to create getters and setters as methods to be able to modify the data in our main function. So yeah, that's about it. If you guys have any questions, please let me know in the comments. If you guys have any other further questions, please let me know. And thank you for watching. Hey guys, it's Solbyte, and today we're going to be going over inheritance. Inheritance is a very important and big topic in object-oriented programming. As you continue your programming career and the more that you use classes, you will undeniably use inheritance during your future projects. So what exactly is inheritance? What is it exactly referring to when it comes to object-oriented programming? So in object-oriented programming, there are basically two types of classes. There is the base class. You could think of this as like the master class or like the parent class. And then we have derived classes. Derived classes you can think of like child classes. They derive from the base class, the parent class. So basically we can use this in a way that, so for instance, let's say we're building a website or some kind of application and, we've created the class user. Well, for certain projects, users, I mean, there can be a multitude of different types of users, right? I mean, there can be free users, people that are using the application or website for free. There can be paid users. They can be admin users, moderators, all different types of users, just totally depending on what kind of project that you're making. And so we would, let's say we want all of these methods and members to be inherited into those specific types of users. So let's go ahead and get started with our example so that way I can kind of show you. We're going to create a paid user derived class. So we're going to create a child class from this much larger parent class. So let's go ahead and do class paid user. And the way that we inherit from the base class is we add this colon and then we add the base class. So this for the syntax is basically saying that we are creating this new specific class and we want to inherit the methods and members of user. So let's go ahead and start creating some new things for our derived class. So let's go ahead and public, and if you don't know what public is or private, please go back to my first video in this series. We're going to really be using a lot of access modifiers today, and if you don't, if you're not already somewhat familiar with access modifiers, this tutorial might be, you might be a little lost. So please go back and look at those, or go back and look at that video if you haven't already. So let's go ahead and create, or let's do a private access modifier as well. And let's just add a new member. So let's see, paid member, what do we want to keep track of? Well, I think in my next video, I'm going to create a function that allows maybe a paid user to, I don't know, maybe gain money, or I don't know, gain some other kind of feature depending on how long they've been a paid user for. So let's say we want to keep track of how long the user has been a paid member. So let's just make a integer variable called paid history. So this will be a variable, and let's say we'll make this in weeks. So 1, if this variable has the value 1, then that means 1 week. They've been a paid member for 1 week, or if it's been 2, then 2 weeks, etc. So, and now let's go ahead and create a function, or sorry, a method. In classes, it's called a method that will print the paid history of our paid user. So let's just do cout, and let's get the name of our user here. And then we'll do has been a paid user for, let's do paid history to show the amount of weeks. And then let's go ahead and specify that it is in weeks. All right, perfect. All right, so we have our function here. And now, oh, don't forget the semicolon here for classes. I sometimes forget myself. So that's why we were seeing that red line there. But anyways, let's go ahead and continue. So yeah, we now have the paid history method that will allow us to see how long a user has been a paid user for. So now let's just go ahead and try to use this. So we'll make this user1 a paid user. So now this is a paid user object, which derives features from the base class user. And let's go ahead and just do user1 paid history, and we will just print that here in the terminal really quick. So go ahead and compile, and this should work just fine, right? So NA has been a paid user for a lot of weeks. Oh my goodness, what number even is that? It's something in the billions, I think. I don't know. But anyways, yeah, clearly this is not a good thing. And if you remember, in our constructors video, we went over why something like this would happen, and it's due to the default constructor that the compiler gives a class that does not already have a defined constructor defined inside of it. And you might notice the NA that is down here, and clearly that's actually correct, because up here in the base class, we used the default constructor, we defined the default constructor to give it the name NA and the age -1. And that is because it is still able to use the default constructor derived from user. However, because paid history is an entirely new variable, totally specific to our paid user class, it doesn't really know what to do with it, so it just gives it a default value. So it's good, or it definitely would be needed here for us to create a constructor for this derived class. So let's go ahead and do that really quick, so that way we can avoid any issues like this. So we'll go ahead and create the constructor. And if you haven't seen my constructors video, please go and check that out before as well, because we're going to go a little bit more into detail about what constructors can do in this video. So now we're going to set it up kind of in a very similar way. So up here, let's see, we passed in string name and int age. So let's go ahead and just kind of do the same thing here. String name and age, and now we'll have another one, an integer variable for weeks. So perfect. Now recall that we already have this constructor up here that tells the program how to build the object based on these two variables. So we can actually reuse this down here. So the way that we can do it, the syntax needed for it is we add a colon there, and we could just use the constructor from the base class, and then use name and use age. So now this will assign the name and the age for the paid user object in the same way that it would for this constructor up here in the base class. So that's awesome. That makes things a lot easier for us. So, and now we just need to go ahead and define the weeks and where that needs to be stored. So let's do paid history instead of equal to weeks. So perfect. Now we have created a constructor that allows us to avoid any issues with, memory overflow or anything like that. However, if you do see down here, it now says that there is no default constructor for paid user. And that's because if you remember from my constructors video, I said that whenever you create a constructor for a class, the compiler no longer uses a default constructor. So now this is treated as the constructor that it will use by default. And down here, we're not using it. And if we wanted to use it, we can do paid user And let's go ahead and add some values. So we'll do Solbyte, do 22 as the age, and let's do 2 weeks. The paid user has been a paid user for 2 weeks. So let's go ahead and run this just to make sure that it works properly. So go ahead and compile that, and it should work just fine. Yep. So Solbyte has been a paid user for 2 weeks. It's perfect. So clearly this is constructing this object just how it needs to. But once again, default constructors sometimes will be needed. Sometimes it's actually very good to create the object and then fill in the values later. So what we can do is we need to create a default constructor the same way that we did up here, right? We created a normal kind of constructor that allows us to fill in the name and the age. Then we also created one that would allow us just to use, just to create the object without defining any values yet for it. So let's go ahead and do the same thing here. And it'll be very similar syntax. So we'll just do paid user, and we'll just do that. And then we'll add a colon and do user. This way we can also use the default constructor up here. So that's kind of what we're using for this right here. So that way it, assigns the same value. So therefore, if we do this, then user1 will be, will have the name NA and the age -1, the same way that it would if it was just using the base class user. So let's go ahead and we still, however, do need to define the paid history, of course. And since it is, a brand new user without, any sort of history, let's just go ahead and assign paid history to 0. So now, as we can see, the red line has disappeared, and let's go ahead and just try to run it just to make sure that it does indeed work for us. And it does. So NA has been a paid user for 0 weeks. Let me go ahead and make some comments here. It's always a good idea to organize your code, especially as it gets much larger, as ours is right now. So we'll go ahead and just kind of add a little bit of comments here and there. So perfect. So we were successfully able to create a paid user and, derive a lot of functionality from the base class. But now I want to bring up 2 very important points that kind of dive into the accessibility of these derived classes and some errors that you can run into if you're not careful. So let's say instead of, showing the paid history, let's just say we want to get the name. Let's just get the name of user1 instead. And as you can see, we get a red line here. And that's because it says that get name is inaccessible. Why is that? Well, so just like we actually had to, of course, we have to kind of define what methods and what members are public in a class, we have to do the same thing for when we derive those members and methods from a base class. So we need to actually specify that we are getting the public members and methods of user. So we need to type in public. All right, perfect. And now if we scroll down, we can see that the red line has disappeared, and I'll run it one more time as well, just so that way we can see that it does. Oh, never mind. It doesn't do that. Why does it not do that? Oh yeah, no, I'm sorry. I'm slightly dumb. Okay, I'll do that. I'll do this now. Okay, this, I forgot this of course returns the string. It doesn't print the string. So sorry about that, little hiccup there. But yeah, anyways, now we can use the getName method from the base class in our paid user derived class. So another area that we see getName pop up is right here in paid history. So what happens if instead I want to just use name, right? I just try to access the name. Well, obviously it's inaccessible, and that is because we made these members private, right? So these are hidden. These literally cannot be used by anything outside of this class here, right? But, what if we want our derived classes that inherit from this base class to still be able to have access to their name and their age, and still be able to use those and modify those. So in my intro to classes video, I actually brought up that there are 3 different access modifiers. There's private, public, and protected. Now, if we want our child classes, our derived classes, to be able to have access to these members that it's inheriting from the base class, we can put these members under the protected access modifier. So I'm going to go ahead and do that really quick. And as we scroll down, we can see that now name is totally accessible in the paid user class. And a good way to kind of remember it is that the parent always protects the child. So these members are hidden except for its derived classes. So that's why protected is kind of like a middle ground for some instances. So yeah, now if you ever do want these members that you want to be hidden throughout the rest of your code, because I mean, if we go here, we can still see that name isn't accessible, right? But if we want to use or modify those members in the derived class, we can do that by making those members protected in the base class. So yeah, hopefully everything is making sense so far. Inheritance is one of those things that you kind of have to get your hands dirty and just kind of begin testing it and experimenting it with your own ideas, and just get some practice with it. When I first learned about inheritance, I was slightly confused at first, but over time you really kind of start to grasp it a lot easier. So and there's more detailed things that we could go into for this kind of stuff. Like for instance, a more acceptable way of initializing this paid history value is by doing paid history 0. And this essentially initializes paid history to 0. Same exact functionality that we just did, but this is usually a lot better for the future, because a lot of the times we may not be initializing an integer variable. We may be initializing, like an object, or, something much more complex. So just many different things that we could really get into. But for the sake of simplicity and just kind of getting the idea across, it's good to just kind of play around with this and try to understand what it's doing. And yeah, just keep practicing, and eventually it'll click just fine. And if not already, which if it does already click, then perfect. You are in a more advanced field for object-oriented programming. So perfect. So yeah, if anyone has any questions, please let me know in the comments below. And in the next video, I will go over abstraction. And after that, we will go into the entirety of polymorphism. So definitely make sure to watch the abstraction video if you intend to understand the polymorphism side of object-oriented programming, because it is a very important topic and it kind of derives from inheritance and abstraction. So yeah, anyways, thank you guys for watching, and I'll see you guys later. Hey guys, it's Solbyte, and today we're going to be going over abstraction in object-oriented programming. So last time we went over inheritance, and inheritance is pretty crucial to abstraction and my next video, which will go over polymorphism. So make sure to go watch that if you haven't already. If you did already watch the inheritance video, or if you just already know what inheritance is, abstraction will make a lot more sense as far as just its functionality. So make sure to go and watch that. So yeah, so what exactly is abstraction? For the most part, abstraction, you can think of like hiding complexity from the end user in a way, hiding complexity so that way it's easier for other developers to come in and be able to implement whatever is needed. So abstraction is really important, and it's just a really good practice to keep clean code, keep clean code, and yeah, just be able to use object-oriented programming efficiently. So it's better to, or it's much easier to kind of give you guys an example of what abstraction is rather than explaining what it is, because abstraction is in of itself abstract. Yeah, so today we're going to be creating one abstract class, and I'll go into this in just a second, and then two derived classes that will basically provide the implementation of a method from the abstract class. So let's go into the abstract class first. So what exactly is an abstract class? So we'll create a character class here, and we will use the access on modifier public. And so an abstract class is basically a class, by its definition, that has a pure virtual function. So if you don't know what a pure virtual function, basically it's basically a function that is saying this function, this method, is not supposed to be implemented in this base class or in this abstract class, because character is also in this program technically going to be a base class for the rest. So basically the pure virtual function is promising that the implementation of this function will be defined in these derived classes, but both of these classes will share the method, but they just have to define and implement it themselves. So let's just kind of show a little bit of an example. So let's make a function. Let's do a function that returns a double, and let's say we're creating like a game. So let's do like a power stat, right? We'll do something like that. And then the way to show that it is a virtual function is using this syntax. We have to set it equal to 0. So basically this right here has no implementation. There's no functionality of this function yet, but it will be shared with these classes down here. But because the power stat, for example, or how the power stat is calculated will be different for both of these derived classes, it's good to give it a virtual function and then let the implementation be done in these classes down here. And whenever the virtual function is created in our character class here, it now makes this class an abstract class. And there's one very important rule about an abstract class, and that is that we can no longer create objects with this class. So if I come down here and I try to create a character object, let's call it Soul, we get this error that says the object of an abstract class type character is not allowed. So an abstract class cannot create an object. Only these derived classes that have the implementation of this pure virtual function. And I think in a later video I will go a little bit more in depth about what a pure virtual function is. There's a little bit more to it that I could go into, but for the sake of just understanding what abstraction is, it's good to kind of just leave this here. So, all right, so now let's create the Knight class next. So let's go ahead and do class Knight, and we're gonna have it inherit from the public methods, from the character class. So perfect. Then we'll go ahead and do an access modifier as well. So let's see here. We basically defined that there will be a power stat function that will return a double here in the character class. So now we need to provide the implementation of this function. So we can do that by just doing double power stat. So writing the name how it needs to be how it was in the character class, and then we can add the keyword override. If I can spell it, there we go. So this kind of just tells the compiler that this function here is to be overridden from whatever is written in here. Because we'll go into more of an example during my polymorphism video about how you can actually technically have some kind of functionality for this function up here, but depending on the derived classes, they could be overridden down here. And if there is no function here, then it will just do the functionality from up here. So we'll go into more of a detailed look with the polymorphism video, but for now we're just going to keep things simple and just kind of override the function for each of these classes and just go from there. So for the sake of simplicity, I won't add some kind of power statistic algorithm to calculate the knight's power stat. Maybe in a later video, I'll make a full-on project utilizing everything that we've learned in object-oriented programming. But for now, let's just return a simple value. Keep it kind of simple. So let's say that the power stat for a knight is 8.5. Perfect. So now let's go ahead and do the same thing for the healer class. So we'll do healer, and then we will have it inherit the character class, the character base class. And then do public, and we'll do the exact same thing. All right. So override, and then let's have it return, let's do 4.3. Healers are a little bit less powerful, but you know, they can heal. So they're pretty beneficial. So anyways, so yeah, now we have these two functions that do different things. However, they are defined, or, you know, they are going to be inherited from this abstract base class of character. So let's go ahead and just kind of show an example here of how we can, or, you know, showing that it actually works. So let's create a knight. Let's name him Cedric. Did I name that wrong? Great. Okay, there we go. Cedric. And this is a very basic example. I know that, you know, I don't have any constructors or anything like that. I'm just trying to, you know, show you guys the basics. So anyways, let's do healer and let's name her Mary. All right. So now let's have it where we can see Cedric's power stat, and we'll do the same thing for Mary's power stat. So let's do Cedric, and then we'll do power stat. So this should show us 8.5 whenever we print out the code. So let's go ahead and do an inline. Then we'll do the exact same thing for Mary's power stat. And let's see here, power stat and inline. Perfect. So yeah, now we have this. So let's go ahead and open up our terminal and try to actually run this. So let's go ahead and compile it and see what we can get out of this. All right, and so as we can see, Cedric's power 8.5 and Mary's power 4.3. Now, of course, these are just some basic statistics for the knight class and the healer class, but it just kind of gives you an idea. I mean, these can be full-on functions with, you know, totally unique functionality, totally specific to the healer class or the knight class. But it will, you know, the reason that we want to use this virtual function here is so that way we kind of show that the methodology, the methods will be implemented in each one of these derived classes. And you can think of it like, because whenever we create this class knight and healer, you know, obviously we need to implement the functionality for the power stat function or method. And you can think of this inheritance as kind of like a contract, like you're promising to provide the implementation that is derived from character, right? And of course, we can still, you know, inherit lots of different things from character that don't need to be implemented directly here in the derived classes. But for anything that is a virtual function, we're kind of just stating that we intend to have this function for each of these derived classes, but implement them differently depending on the class. So, all right, and yeah, that's kind of a basic example of what abstraction is. And if you don't understand completely just yet, I recommend getting some practice with it. It just kind of makes the code a lot more readable. And, you know, it's a good coding practice to do things like this just for readability and, you know, for other developers that may come in and help with, like, you know, open source projects or, you know, whatever else. So This is really good practice, so I do recommend learning it and understanding it. And we're going to dive more into it during my polymorphism video, which will be a little bit of a longer video. Polymorphism kind of takes away from the inheritance and the abstraction parts of object-oriented programming. So we're going to look more into this in my next video. But for now, this is just a basic example of how abstraction works. So yeah, if you guys have any questions, please let me know in the comments below. And thank you for watching. Hey guys, it's Solbyte, and today we're going to be going over polymorphism. Now, polymorphism is a pretty big topic in object-oriented programming. It's a very important topic, but it's also to me, it's a very cool topic because of just the amount of functionality and it really just adds a really powerful tool to your tool set whenever you start making projects, especially as they become a lot bigger and a lot more robust. So yeah, we're gonna go over polymorphism. So by its definition, polymorphism is basically a way that we can manage derived objects using base class pointers. Pointers of the base class. All right. And if that does sound confusing, it's because it's kind of a confusing topic, but just try to stick with me and, I'll show you guys some examples. Before that, I do want to kind of show you guys a little bit of our code here, just right before we get started. That way you guys kind of understand what we're going to be doing. So I have a lot of these to-dos here. We are picking up from my last video where I covered abstraction. And during that, we created a base class character, and then we created two derived classes of knight and healer. And yeah, we went over abstraction and how we can use virtual functions, pure virtual functions, or just a normal virtual function, to implement different functionality depending on the derived class. Today, we're kind of going to be picking up where we left off, but I did add some things. For instance, I kind of added some attributes up here that are protected, including the name of a character and their HP, otherwise known as their health. These are protected in the access modifier, which if you remember is basically like hiding the attributes, however still letting them be derived into the derived classes. So that means that knight and healer both have name and HP attributes derived into them. However, if we try to, down here, if we try to access Mary's health or Mary's HP, it's not going to let us in any way. So that's kind of what protected is. If you guys didn't see my video when I went over the access modifiers and when I went over inheritance, which is when I covered what the protected access modifier is, please go back and check that out, or go and see another video about it. Pretty important topic. Just try to make sure you understand it. And then we have a constructor here that just takes in the name and the HP, and then assigns the name attribute to the name parameter, and same thing for the HP. So that's kind of what this constructor is right here. I didn't create a default constructor. I just I want to show you guys what I need to show you guys. I'm aware this video might be a little bit longer than most of my other ones, so I want to kind of get through and make sure that you guys see the important bits of polymorphism and not waste any time. So we have a get name and a get HP, which are getters. I even added the const keyword, which you guys might already be familiar with. It's a pretty basic topic. It just means that we're not changing HP. We're not changing any sort of attributes or anything about the object. We're just returning a value, or it's a constant method. It's not going to really change anything. So and then I also added a print info, which will be really easy for us to implement later down the line when we need to implement more of the main functionality for the program. So just kind of prints the name and prints its respected HP. So yeah, and then I have these comments here stating that we will implement a take damage method for each and every one of these. And for this one, it will be a virtual function. And for these, we will override that virtual function with unique functionality depending on if it's a knight or a healer. And then yeah, for these derived classes, we have the constructor using the same constructor for the character. That way it assigns the name and the HP the same way that the character constructor does up here in the base class. So that's good. And yeah, that's kind of all you really need to know right now. We are, of course, inheriting from the base class character for the knight and the healer. So let's kind of go over what polymorphism is, and polymorphism basically requires pointers and references to be used. Okay, so if you guys don't know a lot about pointers or references, or maybe you are a little fuzzy in that area, I do recommend making sure that you guys know that before this, because it will get kind of complex if you don't already know about pointers and references, and how they relate to memory addresses, and how they work in general. So make sure to be brushed up on that before we dive into this. So yeah. All right, so let's go ahead and get started. So we're going to create a base pointer. So it'll be a pointer of the type character. All right, if I can spell character, I don't know if I can. There we go. So pointer of the base type, a pointer of the base type character. So we'll just name it C pointer, and we will assign it. So I created a knight up here named Cedric, and I created a healer named Mary. We have the name parameter and the health parameter, a double right here. So what we want to do is I'll just kind of show you guys what we can do with this functionality here, okay? So basically, let's set it equal to the reference of Mary. All right, so there we go. So now this pointer is pointing to the derived object of Mary. All right, so now let's try to go ahead and get the print info function out of Mary. All right, so we're going to use the character pointer, and we're going to use this syntax. You guys may or may not be familiar with it. It's kind of like using an arrow, and we're going to use the print info. All right, so now basically what this is doing is it is pointing to Mary and her implementation of print info, which will be obviously similar to this. However, it will include her HP and her name. So let's just kind of go ahead and show that really quick. This is kind of more so a review. We kind of covered something similar to this in a past video. So let's do compile the game.cpp and then execute. We get Mary 10. Perfect. So this is basically polymorphism. And what I mean by that is we are able to manage the derived object using a base object pointer. And this is just its functionality. I'll show you guys kind of some cooler ways that we can use it as well, especially if the functionality of print info is different, right? Which we will get into here in just a second with the attack features and all of that. So let's create the attack function. Okay, or I guess it might be better to go ahead and create this functionality up here. So yeah, let's go ahead and do this first. We'll do a take damage function. And this is more so just kind of a review of the virtual function and abstract classes. So let's go ahead and create a virtual function up here, take DMG, and we will pass in a double DMG. And we're going to have this not be a pure virtual function. We're going to have this just be for the base class character. So that way it's consistent with how it's supposed to be if we were just using like a character base class. So let's just have it where the HP will decrease depending on the amount of damage is invoked on the character. So pretty simple. So now let's do some overriding. All right, so we're going to go down here and we're going to do the void take DMG, and same thing. I'm going to do the double DMG. I'm going to add the override keyword here. And so I want the knight and the healer to take damage differently. Because I guess knights are a little bit stronger, or you know, they might have armor. A healer is a little bit weaker. They may not have as much armor on them. Whatever. Look at me trying to explain video games. So what we're gonna do is we're going to reduce the amount of damage taken if it is a knight, and actually increase the amount of damage taken if it is a healer. So let's do double. Let's do n. I'm bad at naming variables, and we'll do DMG minus 2. So if DMG is 10, the knight will take 8. All right. And let's do a little, let's do a little check here to make sure that it's not less than 0. Because if it is, then you know that's I don't even want to know what happens. So let's just do if n is less than 0, then we'll just set n equal to 0, just to avoid any sort of errors that may arise from that. Yeah, and then we'll just do the exact same thing. Now we'll just decrease the HP by the amount of n, because n will reflect the reduced amount of damage given to the knight here. So, and now let's kind of do a very similar thing down here. All right, so we're going to do the void, take DMG, send the double DMG, and then do the override keyword, and we're going to go down here, and I want them, or you know, I want the healer to actually take more damage. So we're going to do DMG plus 3. Why not? So sad day for healers, but anyways, so the healer will take more damage, and we'll do the exact same kind of functionality here. We will decrease the HP by whatever n ends up being. So if DMG is 10, then the healer is unlucky enough to take 13 hit points worth of damage. So this kind of just is a review of the abstraction tutorial that I did in my last video. So yeah, basically, you know, virtual function, and then these functions override it depending on the functionality we want in the derived class. It is important to keep in mind that we can actually still create an object of character, because this is not a pure virtual function. We are defining how damage is taken. So this technically can still be created into an object. During my last video, I went over abstraction. We created a pure virtual function, which looks like this actually. We need to set it equal to 0, and that is a pure virtual function. And this basically makes it where we are promising to provide the functionality in the derived classes instead of in the base class. But for you know, for this example, we're going to use it just as a normal virtual function, which just promises that, you know, like we do have this functionality here, right? But instead of using instead of redefining the function here, we are instead overriding the function, right? So now this decision of which functionality to execute is now made at runtime using the virtual keyword for the function instead of at compilation time. And if you don't understand, it's okay. I may go into a more detailed description in a later video about kind of how, you know, the dynamic binding and static binding works. So, but this is done doing dynamic binding, and it's one of the better methods, or, you know, the most ideal method for what we're trying to implement here. So yeah, let's just get back into polymorphism down here. So we now have the take damage function, the take damage methods in our objects. Okay, so now let's create another function really quick. Create an attack function, and this is going to be the polymorphism that you guys will see the most. And so this is very important. So we're going to just create attack character, right, as a function, and what the parameter is going to be, all right, is we're going to make the parameter a character reference. Okay, let's call it C. So a character reference. Okay, so that means that whatever is passed in here will be referring to a character object, right? So let's go ahead and add some functionality to it. And then I'll kind of show you guys more of an example. All right, so let's just have it where, or actually let's do, let's do print info first, actually. Do print info, that way we can see it before, you know, we can see their statistics before the damage was done, and then we can see it after. So let's do, take damage now. Take DMG, and we will do the damage at 5.1. So there we go. And then we'll do another print info at the end of it as well. So let's go and do that. And one more thing I do want to actually do really quick is I want to just create a character, character object. That way you guys can kind of see some of the functionality that I'm trying to represent here. So we'll just create a character named Harry and give this character 10.0 hit points. All right, so this is just a normal character object from the base class, and we can do this because our base class is not an abstract class, which would happen if there was a pure virtual function here. However, because it's just a normal virtual function, we are allowed to do this. All right, so now that I have these three guys, I want to kind of show you guys something really cool. We're going to get rid of this pointer for right now. We don't really need it at this current point. So what we're going to do is we are going to attack a character. Now, obviously, we need to pass in the reference of a character, so let's just do Harry. All right, and let's just make sure that this runs good and fine. That way we are not getting ahead of ourselves here and, you know, implementing more when something doesn't work. So we see Harry before the damage was taken and after. So looks like Harry took exactly 5.1 because it's just a normal character object, which just takes the damage without any sort of reduction or increase in damage. So just a normal character. Now, what happens if we add Mary or Cedric here, right? Well, let's add Mary here and just kind of see exactly what happens. And see what happens is Mary is having a very bad day. She is now at 1.9 hit points. That's terrible. But basically what I'm trying to showcase is the fact that we can pass in a derived object into this function, because this is using polymorphism. This is a polymorphism technique here. We can pass in the derived object into this function here because Mary is a character, right? Mary is indeed a character. And so therefore she is totally legitimate as a parameter for this kind of function. And of course, the same thing for Cedric. So, and I do want to showcase, I guess, how little Cedric will take compared to Mary here. Yeah, so Cedric still has 6.9 hit points there. So that's good. Good for Cedric. But yeah, this is just kind of showcasing how we can use polymorphism in a way that allows us to pass in derived objects into functions like this, right? So basically you can think of polymorphism like kind of as a way of allowing a reference, or sorry, a object reference or an object pointer to refer to a derived object, right? And this can be very, very useful for managing objects outside of certain scopes, and a lot of dynamic functionality that you can also implement in the future. So like this example here is us assigning different types of objects to the same reference type using this kind of function up here. So we went over the pointer, we went over the reference of how everything works. And yeah, now let's kind of get into some more practical examples of how this can be really cool and how we can use this for the future as well. So what I'm going to implement here is we are going to do one final thing for this video, and that is creating a party of these three people, these three characters, and then we're going to see them all get attacked in a for loop, essentially. So, and the way that we're going to do this is using a heterogeneous collection. Sorry, I always have trouble pronouncing that. but a heterogeneous collection. And basically what that means is it is a data structure of different data types, right? So clearly these are different object types, right? A knight is not a healer. A healer is not a knight. A character is neither of these, right? So in what we want to do is we want to create a party of Mary and Cedric here, right? And we can do this using an array of character pointers. All right, so let's kind of demonstrate this really quick. So we're going to create an array of character pointers. We're going to name it party. We're going to have it just be 2 people. And in this array is going to be the reference of Mary and the reference of Cedric. All right, so we're going to do Mary, and then we're going to do, and then we're going to do Cedric. All right, perfect. Nope, not perfect. What did I do? Did I miss something? Oh, wait, do these go out in front? They do. Okay, cool. Sorry. Anyways, yeah, so the reference of Mary and the reference of Cedric. So this allows us to treat this array and do the same functionality onto the array, but of course, these derived objects will behave entirely depending on whatever their unique implementation is, right? So now let's go ahead and do a little for loop and attack these party members and see how they can handle certain damage. So let's actually do let's do a double EMG here, and let's replace this with the parameter. That way it's that way we can use it up here, or sorry, down here, and actually start doing some things. So let's see, what do we want to do? We want to do a cout, and let's just so that way we can see before attack and after attack. All right, so that way it's a little bit more organized for us. I'll do just do the same thing down here, just for after the attack. So after attack, there we go. All right, and then what we're going to do is we're going to do a for loop, and we are going to showcase the statistics of both Mary and Cedric before the attack, and then we're going to do the exact same thing after the attack. So we're going to do int I, just basic for loop here, 2, and then I plus. Let's go ahead and implement this. So now we're going to iterate over party I, and then in order to, just kind of like how we did with the pointer, we need to use this little arrow here to do the print info function. Perfect. And then let me just go ahead and copy this really quick and bring it down here as well. All right, there we go. All right, so now let's actually, unfortunately attack these guys. All right, so let's do a for loop again, and we are going to use this for loop to attack both all of them, using the same functionality, just using the attack function, the attack character function. And of course, it will behave differently depending on which object the function is passing into it. So we'll do attack character, and then in the parameter, we will do the specific iteration. And then very important, make sure to dereference the pointer, because obviously we need to point to the object that is at that memory address. So just, just pointers, if you guys know how pointers work already. So there we go. And so now we should get a different result compared to the before attack and the after attack. I'm just going to clean this up a little bit. All right, perfect. So, all right, so we have a party here of 2 people, Mary and Cedric, and then obviously we have them defined up here. And we are using this for loop and using this unique array of these derived objects, which are both character pointers, right? So now let's just go ahead and see what happens. And this is the type of stuff that gets me excited because, just having a tool like this in your arsenal for development, game development or whatever else is incredibly powerful. So, all right. So let's see here. What happened? Oh yeah, if I'm still printing the info somewhere. Wait, why did it print twice? What happened? Oh yeah, okay, sorry. I forgot that we actually end up printing info inside of the attack character. I'm actually probably just gonna go ahead and take this out because I mean, in attack character, all we wanted to do is just attack the character. So, my mistake, my mistake. Let's go ahead and do that again. There we go. So, Mary and Cedric both have 10 before the attack, and then after the attack, Mary is struggling at 3.8, and Cedric is doing just fine at 8.8. So, perfect. So this kind of just gives you an idea for what polymorphism can be used for, and, once again, just think of it as allowing us to use object references and pointers to manage derived objects, right? Objects of different types. So this is very, very useful, and I could probably make a series just showcasing the amount of things that you can do with polymorphism. It's really kind of a difficult thing to go into in just one video, but you guys now have the main bits of information, the more important bits of information, and now you guys can also see kind of how inheritance and abstraction really kind of tie into it all. And so yeah, it's perfect. So if you guys have any sort of questions or anything else like that, let me know in the comments below or check the description. I'm going to leave some sources like I do in most of my videos for if you guys are maybe looking for more information regarding this this kind of functionality. So definitely go and check that out if you guys would like to, or just let me know in the comments. And yeah, that's about it. So thank you guys so much for watching. Hey guys, it's Solbyte, and today we're going to be going over polymorphism again. I decided to make a part 2 to polymorphism. If you guys have not seen part 1, I went into detail about how we can use polymorphism for many different cases using base class pointers, and how we can manage derived objects using those pointers. But in today's example, I kind of want to go over some more of the types of polymorphism. That way you guys kind of have a much clearer and more, a much fuller understanding of what polymorphism actually is by its definition. So polymorphism has two types. There's compile time polymorphism and runtime polymorphism. So the basic definition of these two types is compile time polymorphism is when the program decides what members or functions to run at compile time, and runtime polymorphism is when the program decides which functionality should execute at runtime. So yeah, basically it's just the program deciding what to do either at compile time or at runtime. And these can look very different. There's many different cases where some things are decided at compile time, some things are decided at runtime. But in terms of polymorphism, I'm going to show you guys 3 examples today, 2 going over compile time polymorphism, and 1 going over what exactly runtime polymorphism is, which we've actually kind of covered runtime polymorphism quite a bit. I mean, even in abstraction, we were kind of doing a little bit of runtime polymorphism. So, but today we're going to go a little bit more in detail about the compile time polymorphism, and a little bit, and just a little bit more into the definition of runtime polymorphism. So the first example is function overloading. So this will happen when we can create, so basically what we can do is we can create 2 functions of the same name, but depending on the parameters that are passed into that function decides what function actually runs at compile time. So let's kind of show an example. So firstly, I have a base class animal and a cat class that derives from animal. So we're going to go a little bit more into this during the runtime polymorphism, but for right now, just basic constructor, a eat method here, and then some protected members here. So what I want to do is I want to create 2 functions called eat. However, I want them to behave differently depending on what parameters are passed in the main function. So let's go ahead and do this. So firstly, let's go ahead and actually pass in a parameter. Let's just do, probably just do food. I think that's probably a good one. We'll do string food. So, and then here, we'll leave it open-ended to show what food the animal is eating. All right, and now what we're going to do is I want to go ahead and copy this function, and we're just going to add it down here as well. But this time, let's say we want to pass in how many grams of food. Yeah, let's do that. Let's do the grams, the amount of grams of food. So we can do is eating, we'll do grams, and then we can just do this, grams of, yeah, we'll just do that. Because I'm trying to think of what food string I would end up passing in. So one thing I do want to go ahead and do really quick is I actually want to show you guys some new syntax that you guys may not be familiar with. That is very good and very useful for strings and objects that are passed into functions. So whenever a string or an object is passed into a function, these are regarded as kind of expensive because they can take a little bit longer, and you know, they also, I mean, you know, depending on what we do. So here, I'll just show you guys a little bit of an example before we do this. So let's take Max and let's give him something to eat, and let's just, for the sake of this, create a string, and we'll just call it food. Why not? And then let's say pizza. So we have an animal eating pizza. That's kind of concerning. So now what we're going to do is we're just going to go in and pass in food, right? And this is, you know, like, it works, you know, by all means necessary, but it's not really good, I guess. I mean, especially as you want to pass in different types of parameters, especially objects as parameters. This is not as good, because what is happening is, if you guys don't know about pass by value and pass by reference, what's happening is it's actually copying this string, right? Which takes, you know, a lot more memory than integers or doubles. It's copying this string into this function. So now, whenever this function is running, we basically, like in memory, try to imagine, we basically have two food variables. And I mean, obviously, you know, we're going to be okay running it, but as far as efficiency goes, especially as we build bigger and better programs, we want to kind of avoid doing this by all means necessary, especially for objects. So the way that we can do this, or kind of fix this, is we're going to have it pass by reference instead. And another good practice is to add const. And what this is doing is basically, since now it's passing by reference, what this means is, I mean, if a little bit of a reminder, if anyone doesn't know, is now it's actually passing this variable itself. It's not copying it into the function. It's now actually, like, the actual variable food is being passed and used in this function. So, and that can, I mean, in our case, like, it shouldn't be a problem to leave out const, because it's not really mutating anything. But, you know, as bigger and more complex functions come about, it's better to add const if you don't want the variable that is passed into this function to be mutated in any sort of way, whether that's indirectly or just, you know, mistakenly, you know. So yeah, definitely const, and then the reference for string food. So we are passing by reference here, and with const we are ensuring that whatever variable is passed by reference here is not mutated in any sort of way at all. So just a little bit of syntax. I just wanted to show you guys this because we will be using it in the other two examples. So just wanted to go ahead and get that out of the way. So anyways, back to function overloading. So here we clearly have two different functions. We have two eat functions, right? Now, what's really cool, obviously these functions are different, they behave differently, but what is cool is we are able to use both of these functions because of function overloading. So for this one, let's specify the amount of grams. Let's just say 2 grams of pizza. Why not? So now let's go ahead and go to the terminal and just see what we can output. If I can spell animal, there we go. And so we have animal is eating pizza, and animal is eating 2 grams of pizza. In this constructor, I made it where every animal is called animal. That way, in a later example, we can kind of see what object is an animal, what object is a cat, etc. So, but for now, yes, this is working just fine. So that's awesome. So this is a form of polymorphism. It's not runtime polymorphism, but it is a compile time polymorphism example. All right, now let's go into the second example, which will go over operator overloading. So this is when, I mean, it'd be easier just to kind of show it, but basically operator, all right, so now we're going to go into the second example, which will be covering operator overloading. So not function overloading, now operator overloading. So let's say we have a class number, right? So this will just be a number object, right? And we will just have everything be public for this. And we will create an int of num. Let's do num. So there we go. And then make sure to add the semicolon, of course. So anyways, now what we want to do is create 2 objects down here. And I would really like for the, or actually let's do a constructor first up here. Yeah. Let's do that first. That way we can actually fill in what is needed. So let's do this, and then we are just going to assign num to n. Okay, there we go. Nice constructor there. So now let's go down here, and let's say we want to give number a, and we will assign it to the value 1. Okay, and then we'll just do the same thing for number b, assign it to 2, and let's try to do some addition with this right now. All right, let's do a plus b. All right, so these are 2 number objects we want to add together, right? However, we can't do this because the program has no idea how to handle these 2 objects with this operator. It has no idea what to do with these data types. Operator overloading allows us to use operators like this for specific data types like objects. So how do we do this? All right, so what we're going to do is we are going to create a function, right? And this function will have the return type of number. So we are returning a number object out of this function. Okay, so, and then what we're going to do is use operator plus. All right, so what this is saying is we are creating a functionality for the plus sign operator. All right, so now let's have it where we can pass in a number reference, and we will just we'll call it n. I guess it's yeah. We'll just do n. All right. And so what this allows us to do is it allows us to define the behavior of when this operator is trying to be used for these 2 different objects here. So we will basically return, we'll do num, and then add it to n.num. All right. So what this is doing is it's adding the num, which is here in this object, and it's adding it to whatever number object is passed into it and accessing its num member to add it to the current num member. All right. So now, as you can see, the red line has gone away. And so now let's just kind of do some cout functionality here. That way we can kind of see what is what and be able to go from there. So I'll just create some stuff like this really quickly. Okay, error here. I don't know why. Wait, what? Oh, wait, sorry. Yeah, so we'll do a.num, right, so I'm going to copy this down here, so B for this one, and then I want to see out C, and we will get C.num. Perfect. So let's go ahead and run this code. We will go ahead and compile and .cpp and run it. And as we can see, A equals 1, which it does, B equals 2, and added together, we get 3. Awesome. So this is another form of polymorphism. This is compile time polymorphism. And yeah, it allows us to be able to use operators like this, including other operators like the minus sign or the equivalent sign, right? If you wanted to get a Boolean comparing two different objects, so which can really be cool as well. So, but this is just a simple example regarding the operator overloading functionality with polymorphism. All right, and now for the last example, we're going to cover runtime polymorphism, which, if you remember, is the program deciding what functions to run at runtime, right? Depending on the specific object. So, firstly, I'm just going to kind of delete some of this actually, and what we want to do is we want to implement a example regarding function overriding. Now, this essentially is what we were doing in my last video. We were using the virtual keyword to create a virtual function that would be overridden if we were using a cat object instead of just an animal object, right? So let's do something kind of similar here. All right, so let's go ahead and make this a virtual function. Virtual. And so what this means now is that at runtime, the program will decide what function to run based on whatever overrides this function here. So let's go ahead and create the eat function down here for the cat. And we'll do kind of the same thing. We'll just do string reference food. And we're going to add the override keyword. This actually isn't needed, override, but you can put it there. I always put it there. So yeah, we're going to just have it where we want, I don't know, the cat to eat differently, I guess. We'll say, instead of eating, let's say is nibbling. Yeah. We'll just do that. So we'll say name is nibbling. Is that how you spell it? Nibbling? I think so. I don't know. I could look stupid right now. I don't know. But we'll just go and do that, and then add basically the same functionality for the cat. So cool. So override. So what happens is that this is function overriding, and this function will be overridden at runtime down here. So let's go ahead and actually implement this for Cooper. Let's do that. So, and what we want to do is we want to create an animal base class pointer, say aptr, equal to the memory address of Cooper. All right. So now we can come down here and we can do aptr and call the eat function. And let's have it where cat food. Let's just do cat food. Perfect. So now let's go ahead and try to run this code and see what happens, right? And I'm going to show another example after this as well, just so that way you guys can kind of really understand what's going on. So cat is nibbling cat food. So this decision to run this function instead of this function is made at runtime, right? Whenever the function, like whenever I typed in, the execution file, that's when the decision to run this function was made, okay? Compared to a compile time decision instead. So very key, very important. And if we create, if we do eat for max, and let's just do animal food, why not, whatever that is. And, we can run this again. We can see that, animal is eating animal food and cat is nibbling cat food, right? So we can see that the function right up here still exists. It can still execute, right? but the decision on what function to run based on the object is made at compile time. Okay, so hopefully that makes sense. I understand that it could be a little confusing at times, but we kind of were doing this from abstraction all the way to this video. So we actually have a little bit of experience now using these virtual functions, even using pure virtual functions as well. I do kind of want to touch on why pointers and references are actually kind of a big deal in polymorphism. So polymorphism doesn't really happen unless we are treating the derived objects through the same common base type, right? So what we want to do for a lot of programs is we want to treat, whatever function this is in the same way that we would treat an animal object, right? So this can be very good for making dynamic programs that, it doesn't matter what kind of object or what kind of derived class, you're creating an object from, it will still be able to work using polymorphism, because the most powerful tool from polymorphism is that we can treat objects in the same way while still keeping their unique behaviors. All right, and that's really only done here with pointers and references being used. That way we can pass in derived classes and treat them in the same way, the same functionality as we would for whatever its base class is. And something very important as well is to bring up the fact that we can't exactly use this derived class or this pointer pointing to the derived class for any specific methods or members. So here we have this meow function that is not even in the base class. So if I come up here and I try to, call that, even though it is defined in the cat object, we can't really run it because of the limitation of how this kind of polymorphism works, right? So if we if we wanted to use meow, the meow function, we'd have to call the cat directly and run it in this way. All right, so we can still definitely use it, of course, but we want to have certain instances where we can, or there's going to be certain times where you want to treat derived objects in the same way, no matter what object they are, while still keeping its unique, their unique behaviors, depending on what functionality you're implementing for the derived objects. So very important. Another key example is object slicing, which I'm debating making a video on. It's a very simple topic, but then again, it probably does deserve a video of its own, but it does touch on these kind of pointers and stuff. So, and it's very important to understand, so that way you don't run into any sort of errors in your code. So I think in my next video, I'm going to cover that. And then after that, I'm going to cover some more specific topics regarding classes. And then we will, what I really want to do is I want to create a full-scale project using all of the main pillars of object-oriented programming, like, encapsulation, inheritance, abstraction, and polymorphism. And we will create a nice project using all of it. That way we can really kind of see how all of it ties into each other and make a good final product at the end of the day. So, and yeah, that's about it. If you guys have any questions, please let me know in the comments below. I'm also going to leave some resources in the description if you guys want to see some different sources speak on this. And yeah, thank you guys for watching. Hey guys, it's Solbyte, and today we're going to be going over structs. Now, structs are very similar to classes, but in case you haven't watched any of my previous videos about object-oriented programming, I'll try to keep it simple and not try to build too much off of what I've already discussed in my previous videos. If you are interested, I have gone from intro to classes all the way up to polymorphism, so feel free to go and watch that. And this will be a part of the object-oriented programming series, because it technically is still object-oriented programming, or at least has the same functionality. So yeah, so what exactly is a struct? So a struct, by its definition, is basically a user-defined data type that will group together members of different data types to create just one singular custom data type. So we can create a struct in the same way that we can create a class, and we can group together a bunch of different data within that the new struct. And the same way of a class, a struct is basically just a blueprint for creating these data types. So we'll do that down here in the main function later, but first we need to actually make a struct. So what we're going to do is we're going to make an item struct today. We're going to include these different data types: an item name, which will be a string, a value, which will be a double, and a boolean, which will classify if the item is rare. So let's go ahead and make this. So we use the struct keyword to identify that that this is a struct. And we'll go ahead and just type in item. And just like with classes, make sure to add a semicolon at the end of it. Very unique to classes and structs. You need to add a semicolon at the end of it. So there we go. And so now let's go ahead and fill in some different data types that we want to be grouped together, all within this singular custom data type. So a struct an item, we want to have a string item name, right? And then we'll do the value. So let's just do a double value. And then we will do a boolean regarding if the item is rare or isn't rare. All right, perfect. So now let's go down here and actually create this data type using the struct blueprint. So we can come down here and we can classify that we are creating an item data type by just saying item. All right. And then we can then put the name of the item. So let's just do a sword. All right. And just like that, we have a sword, which is a data type, which is an item data type. So perfect. Now the way that we can access these these members of the item data type is using the same methodology that we would use for classes. So we can do sword and then dot, and as you can see, we can now access these data types. And if you have a little bit of knowledge about classes, you would know that there's things like access modifiers. Well, for structs, everything is public automatically. So there's no need to worry about access modifiers here. Everything will be publicly accessible outside of the struct itself. So, all right, so let's go ahead and actually create just the sword. Let's just kind of fill in the values for the sword, I mean. So for this sword, let's call it Hero's Sword, okay? And then we'll do the same thing for the value. We'll put, let's see, it will cost 14.5, whatever that means. And then we can do is rare. And we're going to set that equal to the Hero Sword. That sounds pretty rare, so we'll just do true. Perfect. Now down here, I'm going to do some cout, and we're going to see the name, the item name. So we'll just do sword with item name, and then inline. And we'll just do this for basically the other ones as well. So we'll go over here and change this to value, and then we'll do the same thing for is rare. So these will print whatever values are in these members for the data type sword. So let's go ahead and run this in our terminal now. I'm going to go ahead and compile. I misspelled struct. Okay, not my best luck. Not my best luck. There we go. So now let's execute it, and here we go. So we see Hero Sword, which is the item name. We see the value of the sword, and 1, which translates to true as a boolean. So perfect. All right, and let's go ahead and just for another example, let's create a bow. All right. So now we'll kind of do the same functionality. So I'll just kind of copy this. That way I have a good understanding of what we'll do for these. So we'll rename all of this here to bow. And then we will go ahead and let's see, we want it to be called just a basic bow. We'll make it not nearly as valuable, 1.3, and then we'll set this to false. So it's not a rare item. All right, and now let's go ahead and make sure that we can print out the information for the bow. All right, so we'll just do bow for all three of these guys here. If I can spell it, there we go. All right, let's go ahead and rerun our program. And as we can see, we got hero sword 14.5 and true right here for the sword item. And down here we have the basic bow 1.3 and 0 for the bow item. All right, nice. So these two are the same data type. However, we can specify their values and how, basically their uniqueness using the members that are within the data type. One more thing I will bring up is we can actually set some of these to a defaulted value. So we'll just do is rare false. So now we wouldn't actually need to specify this. So now whenever we rerun the program, we see that both of them are now false. So we can have certain members be a default value, and we can actually, of course, change these as well. They don't have to remain that same value. But if you want most items to, always be a certain way, then we can specify that up here. But if maybe you have some items, like very few, that will be rare, then we can specify that again down here and change the defaulted value to true. All right, and that's about it. So if you guys have any questions, please let me know in the comments below. I'm also going to include some resources in the description if you guys have any other, or if you guys want to see some other resources, or just make sure you really understand structs. And yeah, that's about it. So thanks for watching. Hey guys, it's Solbyte, and today I'm going to be going over destructors. They're a pretty important topic when it comes to object-oriented programming, especially in the use cases of when you would want to allocate memory on the heap, and maybe you'd want to do that for an object or whatever else. So yeah, let's go and get into it. So just like a constructor. So what do we know about a constructor? A constructor, you can think of like the builder, so the class is the blueprint for creating an object. The constructor is the builder that actually builds the object and fills in certain members. Like for instance, it can fill in the value in for whatever object is created through the value class. And yeah, so let's go ahead and do that really quick, so that way we can kind of start from a constructor. So we'll do value. All right, and we will have pass in int num. Okay, and then we're gonna go over here and just set in to num. There we go. And so now we have a constructor that whatever we pass in, whenever we actually create the object down here, we'll set whatever we pass in equal to the in member of this object. So that's great. Now a destructor is just, so a builder, a constructor is like the builder. A destructor is the thing that destroys the object when it's no longer in scope or the program ends. So a destructor is automatically called when the program is ended. And so that's why I haven't really gone into it too much in the past, because it was kind of automated. But there are many use cases where you would need to explicitly define what your destructor does for whatever certain reason. So we're going to go ahead and create a destructor. So the way that we do this, it's a bit different from a constructor. And we will use this little squiggly mark, the tally, and go ahead and fill it in like a normal, or sorry, don't fill it in at all. My bad. Do not fill, yeah, so a destructor has no parameters. I was getting a little ahead of myself for later, but yeah, a destructor has no parameters. All right, it just simply does what it needs to. Okay, so I'm actually going to make the syntax a little bit more simple. so that way we can actually kind of explicitly see when the constructor is ran and when the destructor is ran. Okay, so for the constructor, we'll just say constructor finished and then line, and what we will do is we will just see out the value of n. Okay, so there we go. Then I'm going to do the same thing here. So destructor finished. All right. So this will tell us when the object has been deleted. Okay. So let's go down here and actually create an object of value. So we'll just call it number. Yeah, that'll be good. So, and then we will pass in 3. All right. So we don't have to write anything else down here because these will automatically run whenever it constructs and when it destructs. So let's go and run it in the terminal really quick so that way we can kind of get an idea for when these values are, or when the constructor is doing what it needs to do and when the destructor is doing what it needs to do. All right, so let's go ahead and run this. And as we can see, I actually made an error. I never set n equal to anything. I forgot to do that, so let me actually go ahead and do that really quick. Sorry about that. So we'll set n equal to num. So now that should be good. Yeah, so we got just a random value, 686. But as we can see, the constructor did finish and the destructor finished. So both were called during the program's execution. We kind of explicitly called the constructor here using, you know, the syntax, but we never had to explicitly call the destructor. So that's something kind of about destructors. There are some instances where you could kind of explicitly have it do something at a certain point, but for most cases, it will just automatically run whenever the object is or goes out of scope, or if the program ends. So like if we did have a program, or sorry, not a program, a function that an object was created inside of, whenever that function is done running, the object would be deleted by the destructor. So anyways, yeah, so that's, I mean, pretty basic. Destructors just kind of delete the object. And we can actually see this a little bit more explicitly whenever we do things like memory allocation. So we're going to kind of bring up an example of that right now. So we'll go back up here, and what we're going to do is we are actually going to make n be a pointer. Okay, so now n is a pointer. And now we can kind of, if you guys don't know much about memory allocation, I recommend kind of understanding it for object-oriented programming, or, I mean, you don't have to, but when it comes to destructors, that's kind of the most common use case for it, is by doing that. So anyways, what we're going to do is we're going to allocate memory on the heap. So we're going to write new, and int, and we are going to fill in num. So what this is doing is it is allocating a certain amount of memory on the heap for the integer for n. So perfect. I'm going to write a little line here that says that we allocated the memory. Perfect. And so if we do this, it's very, very crucial, all right, to free up the memory, right? As I'm sure many of you guys might know. So, and one more thing too, we need to dereference, and so that way we can actually see the number. So, because if we filled in 3 and then we didn't dereference it, we would just get back the memory address. Anyways, so now we just need to delete n. Okay, so I'm going to write delete n. All right, and then right here I'm just going to write memory released. So the memory has been released from the heap. So now we don't have to worry about any sort of memory overflow issues. So this is a very common use case for destructors and needing to explicitly define them. So now we're going to go down here and rerun the code, and we should get back basically the exact same thing. So we get constructor finished allocated memory. So the constructor allocated the right amount of memory and then printed the number that the n pointer is pointing to. And then after the program has ended, the destructor executed and freed up that memory. So we don't have to worry about any sort of problems caused by memory overflow. And yeah, that's about it. I'm going to leave some resources down in the description below for anyone who may want to kind of look a little bit more in depth about kind of what you can do with Destructors and etc. But this is kind of basically it. I mean, it's a very simple topic, so it doesn't really need too long of a video to really go over. But yeah, very useful for memory allocation. So if your programs rely on something like that, then there's a good chance that if you're also utilizing object-oriented programming, you will need to be able to dive into Destructors. All right, and that's about it. Feel free to leave any comments in the comments down below. Any questions down in the comments down below. And thank you guys for watching. Hey guys, it's Solbyte, and today we're going to be discussing the this pointer. So the this pointer is kind of it's a very useful tool when you want to refer to the current instance. So if you don't know what an instance is, if I create down here a number from this class number, right? If I create a number object num, if I had some kind of functionality in here and used a this pointer, the this pointer would be referring to this specific instance in num. Now, if that doesn't sound like it really makes sense, it's a lot easier to just kind of show you guys. So firstly, we have an integer variable n, and we have a constructor up here that sets n automatically to 0. And what we want to do is we want to create a function, an increment function, that increments the value of n by whatever is specified in this parameter. So one way that you can see this being really useful is, for instance, what if we had int n, right? And we wanted to increment n. So that would look a little weird because, we would have this, which basically does nothing. Okay. So what we can do instead is we can use the this pointer, which is automatically added to every non-static member function in a class. Okay, so this automatically comes with this kind of class. So we can use this, and then we can refer to n. All right, so now what's going on here is this, right? This pointer, it's kind of confusing to say this, but this pointer is now, we're now accessing the n member of this specific instance, right? So whenever this function runs, this pointer will be pointing to the instance that this function is being ran in, if that kind of makes sense. So a good way to kind of show this is if we come down here. Earlier, if we just had n, and then we put in like 2, for instance, we would still get back 0 because it would more than likely just do 0 incremented by 0, which is 0. So, but when we use this, when we use the this pointer, we can now access this member here of the same name and increment it by the parameter that is needed. And this is also useful for, not only when a variable name matches, but also to kind of increase readability as well, because it kind of explicitly states that it is referring to this specific instance. So it can be very useful for readability as well. So let's go ahead and just kind of show an example of this actually working now. We're going to do a cout of whatever n is for num. So we'll do get n right here, and then we will just do it in line. I'm going to go and copy this down here as well. And in between this, we're going to have the increment function. So we're going to do the increment functionality, and let's increase it by 2. So let's go ahead and try to run this now. Clear, and then go ahead and run. And so now we see the value before the increment and the value after. So what is happening is basically, we are taking in the member n inside of num, and we are increasing it by this parameter. So that's kind of the basic parts of the this pointer, and it's very useful for a lot of different cases that we can that I'll probably showcase in my future project video that I'm going to use object-oriented programming to program an actual program an actual full-length program, or maybe not full-length, but a pretty big program. And I definitely will be using the this pointer. So I wanted to kind of go ahead and give you guys a little introduction to this. So yeah, if you guys want to have some more sources to go to, or if you guys want to look a little bit more into this pointer, I will leave some resources down in the description that I like, and some that I even use to kind of brush up on the topic before this video. So make sure to go and check that out in the description. Or if you guys have any questions, please let me know in the comments. And yeah, thank you guys for watching. Hey guys, it's Solbyte, and today I'm going to be going over object slicing. Now, object slicing is something that you will more than likely see at some point during your career. And it happens whenever you assign a derived object to a base object. And whenever you do that, only the base portion of that object, of the derived object, will actually be copied into the base object, if that makes sense. So essentially what happens is that the derived bits, the derived specific functionality, will be sliced off whenever you do that. So it's easier to kind of show you guys an example. So firstly, we have a base class with a constructor, a getNum, and a print class, a virtual void print class. And then down here we have a derived class inheriting from the base class, and we have a constructor for it using the same methodology we are using for the base class. And we also have a print class which overrides the print class in the base class. So I'm saying class so much it's starting to make it hard to speak. Okay, but anyways, so and then down here we are creating an object B and setting the num equal to 1, and we are setting an object D, and we are setting its num equal to 5. So the getNum, if you guys have watched my inheritance video, you'll know that the getNum, because it's not a pure virtual function, and because we don't override it in any sort of way here in this derived class, it's going to behave exactly how it does in the base class. And if I show that to you guys just really quickly, then we will see that we get 1 and 5 down here, which is exactly what they should be. So the base object should be 1 and the derived object should be 5. So that's exactly what we want to see. So like I said at the beginning, object slicing happens when we set a derived object, when we assign a derived object to a base object, right? So that would look like this basically. So if we set B, the base class object, equal to D, the derived class object, some weird stuff starts to happen here. Okay, so I'm going to show you guys the two important things. So I'm going to copy getNum down here just so we can see what happens to the number, right? And then we're also going to use print class. So if you guys had to guess, what do you think will be printed here? What do you think it will say? Do you think it'll say base because it is technically a base object, or do you think it'll say derived because it came from a derived object, and we are assigning the base object to that derived object? So naturally you would think maybe it would still be derived because we are setting our base object equal to the derived object. So it can get a little confusing, but anyways, I'm just going to go ahead and shut up and show you. So we're going to compile, and here we go. So we are seeing that it says base, all right, even though the method in derived says that it should console out derived, right? But it still says base. Now, why is this? So because it's a base object, you could think of it in this kind of way, right? So if if you did this the opposite way, right? And you set like the base object to the derived object, it'd be just fine. Why? Because the derived class is from the base class, right? You could think of it like if we had a base class called animal and then a derived class called dog, a dog is an animal, right? But an animal isn't exactly a dog, right? So that's kind of why this happens, right? An animal doesn't bark only if it is a dog. So therefore, if we had a function that was specifically for barking, it would get sliced off, and therefore it would refer back to whatever sound a normal animal makes, or I mean, I don't know, whatever we would end up putting here, right? So anything that is overridden or any new methods for that matter will be sliced off. So we are only left with what the base class knows. Now, we do get 5 though for this. So because the derived class does have the num integer as a member, it can still be assigned or copied over into this base object. So that still works perfectly fine, but because the base object has knows nothing about this, right? It can't grab that, right? So a reason for understanding this is you may run into doing something like this in the future in a much bigger project. You might be tempted to do something like this. So, and naturally, you sometimes would want to find a solution for doing this, right? And well, you're in luck because I have that solution, and it's using pointers and references, our best friends, pointers and references. So I'm actually going to go ahead and show you guys an example of that now. So the way that we need to do this, if we want to use similar functionality to this, or if there would ever be a reason that you would actually want to do something like this, is we can use pointers and references. And I think I brought up a pretty similar example in the past as well. So, or sorry, in a earlier video. So we're going to go ahead and do that now. So we're going to make a pointer, a base pointer called B. We are going to set it equal to the memory address of D. All right, perfect. So now what we can do is we can use B to point to whatever functionality is in the derived class and still be able to use all the unique abilities of that derived class using a base pointer object, right? So now because we are doing this, we need to set it to the pointer notation here, right? So we got to use these little arrows. Perfect. And so now let's go ahead and go to the terminal and rerun this and see if we can actually get something that says derived, and we do. Perfect. So that's awesome. So this is how you would fix that problem of object slicing. And there will be cases where you might be tempted to set an object equal to another object, or sorry, a base object equal to a derived object. But whenever you start getting, because you won't get compilation errors, you will just get totally wrong data. And that can be sometimes pretty frustrating because you have no idea what's going on there. So this is why I make this video, because I've actually dealt with a problem like this in the past, and I had no idea what was happening. So it's good to know about these things whenever you, or sorry, as you continue your journey in object-oriented programming. And yeah, so pointers and references are always super useful. They're useful for so many cases, including avoiding object slicing. So, all right, and I'm sure there's more examples I could probably get into, but this is kind of the basic. If you know how pointers and references work, the rest should kind of make sense. But I mean, as always, I'm going to leave some references to other sources that kind of discuss the object slicing a little bit more in depth. So feel free to look in the description for those. And yeah, if you guys have any questions, let me know in the comments. and thank you for watching. Hey guys, it's Solbyte, and today I'm going to be going over header files and how we can use them for classes. So firstly, what exactly is a header file? So it works in the same way just as these header files do, right? These include IOStream and include string. These are both header files. These are files that have all of the functionality for things like cout and creating string variables, right? So in the same way, we can create header files to kind of make our main code, like our main program, a lot more readable and a lot more organized, right? So I'm going to kind of show you guys how we can do that today using two different files, the header file and the C++ file that has the implementation of that header file. So I'll show you guys that here in a second, but firstly, we are starting off with this this player class, right? It's got two private members here and a print info function. So, pretty simple, nothing too crazy. I'm actually gonna go ahead and add a constructor as well, just so we can assign the members to, some kind of value. So let's do name equals Solbyte, and we will do power equals 99 because of course. All right, so perfect, there we go. So we have a constructor and we have a print info void function here. And what we want to do, this is a very simple class, but I mean, if you go back to some of my videos that I've done on object-oriented programming, you can see, especially in my polymorphism videos, just how big these classes can really get and how complicated they can really get. So what we want to do is we want to sometimes, and it's great practice to do all the time, if I'm being honest, to separate these, your classes in a header file. That way the main file can kind of just be a lot more organized, and you can just have everything you need to, create the objects and be able to do whatever it is that you need to do with those objects. So anyways, let's go ahead and start talking about what these things are. So first we have a header file. It's going to be denoted by .h. So, and the header file is basically just the blueprint for the class. All right. So same way that a class is a blueprint for an object, right? We're still creating a blueprint, and the blueprint is here in the header file. Now in the C++ file over here, this is the implementation of that blueprint from the header file, right? So we're going to actually be adding the functionality and how the class, or the functions of that class should behave, right? So let's go ahead and kind of get into it. All right. So firstly, or I guess I should, So firstly, let's actually cover something very important about header files. We need to actually tell the compiler that we want to include this header file and that we want to go ahead and define the class, right? So the way that we do this is we use these things called header guards, which are going to be if indef, right? And then we'll use define. All right, and for both of these, we need to add the name of the file with all caps and using an underscore as the dot. We'll do player.h and player.h once again. All right, so perfect. And we still get this red line here because we are missing the indif, right? So we need to add that at the bottom of the code. We don't have to rewrite the file name for this one. We just need to kind of explicitly state the end of the definition, if that makes sense. So anyways, and our blueprint for the class will be encapsulated in these header guards. So very important that you kind of understand that and that you remember to add these. I, for some reason, forget a lot. I don't know how, but I do. So if you do, it's fine. But yeah, very big part and very crucial. So now what we're going to do is we're actually going to copy this class in here in the header file, right? So, and what I want to do is I want to kind of show you guys firstly that we can also add header files into this one too, right? So we can include string, for instance, right? And that'll get rid of the red line here for string, or if I denote it properly or use the right syntax, there we go. So that gets rid of the red line there. And if I did the IO stream, I'd also get rid of the C out as well. But I'm not going to do that because the big thing about creating the blueprint, right? Because this is the blueprint for the class. We define what private member functions we have. We define what public functions we have, or sorry, not private member functions, private member variables that we have, and the public functions that we have for this class, right? But the big thing is we actually don't need to add this implementation of these functions, right? In fact, that's kind of what this this file will be for, is to to add the functionality for these functions, right? But for here, we just need to state that it exists, that we have implementation, or that we will implement it here in this file. But as far as here, like we know that these are a part of the player class. This is the blueprint, and we will have these functions for the player class. It doesn't have to be defined here. We just have to kind of state that it is that it is a part of the class. So, and that's about it for the header file. We mostly just define that the functions do exist and that we do intend to add functionality for it, and whatever other member variables we want to add. And yeah, so the reason that we do this, the reason that we don't define it here, is because it actually makes this header file a little bit more readable. Because these, classes can get really, really big, and there can be so many different functions for what you want to do for a certain object. And so having just a list, right, just a long list of all the functions that you need, separated by comments or whatever, having a very long list of all of that is very beneficial, and just kind of organizes it a lot better. So now what we're going to do is we're actually going to add the implementation. So in order to implement the functionality for that class, we're going to go ahead and include the header file. And the way that we do that is we use these quotation marks instead of the normal brackets that we would use for IOStream or string, right? And so we'll go ahead and do the quotation marks, and we'll do player.h. All right, so now we are including this file here in this file, right? Just the same way that we would include the functionality for IOStream in this file, right? We're just including it. So we're going to include that. And now what we can do is we can now actually start to add the implementation of these functions. So how do we do that? Let's go ahead and do let's do the constructor first. So the way that we do that is we're going to write out the class name, which in our case is player, and we're going to add 2 colons, and then the name of the function, which is player because it's a constructor, and then we can add the implementation. So we can say that we want the name to equal Solbyte, and we can add that we want the power to equal 99. Perfect. So in this way, we are implementing the functionality for these for these functions. And as you can see, we actually, this one right here has a line because it says that it's missing the function definition for print info. But there was one over here, but it went away because we have now defined the definition, the implementation of that function. So, and yeah, just using this kind of syntax up here, we're just stating, we're simply just stating that this is the class, and that this is the function in the class that we want to add functionality for. So we're going to go ahead and do the exact same thing for print info. So we're going to do void player print info. All right, so I had to add the IO stream so that way I can do the cout, but now we can do the implementation of print info. We can do cout, we'll do name, and then we'll do the endl, and then we will do another cout for the power and another nl. Perfect. All right, so now we have the print info function able to actually print the name and then the power. Okay, I had to add the the std syntax because I didn't want to use the using namespace std like I usually do in most of my videos. So if this confuses you, don't let it. It's just just how just how it works. So anyways, but yeah, so now we have the implementation of this player class for these functions that were defined in the blueprint in this header file. So now it can all come together here. So the way that we can start this is we can go ahead and get rid of string, because string, the include string, is already here in the player header file. So it would be kind of redundant to include string again if we're already going to include the player.h. So we're going to include player.h, and as you can see, that red line went away because now it recognizes that we are creating an object called Solbyte, and we are creating it with the player class that is defined here in the header file, and the implementation is defined here in the C++ file. All right, so now we can actually run this program and see that everything should be working properly, but very big point here, make sure that you also compile the player.cpp, the implementation file for the class, because of course we need that to be compiled in order for any of this, to make sense. So we're gonna go ahead and compile both and go ahead and run this, and we get Solbyte and 99. Perfect. So yeah, that's basically it for header files, and that's also basically it for object-oriented programming. Hopefully these videos have been helpful. I'm going to create one more video that will be a code along, and I'm going to create a text-based RPG, and I actually look forward to that. That sounds like a lot of fun, and I'm going to do it using everything that we've learned in these tutorials, polymorphism, abstraction, encapsulation, just everything. So make sure to stick around for that if you'd like to. I'm going to have that uploaded hopefully within the next coming weeks. Yeah, I think I'm going to add a face cam too, just so you guys can kind of see, how I'm thinking and the process that I'm going through. And so yeah, look forward to that. And then, yeah, then we'll be done with object-oriented programming. But hopefully you guys have enjoyed these videos. For my next series, I'm going to do the standard library. We're going to touch on that and go from there. So yeah, if you guys have any questions, I'm going to leave some resources in the description. And other than that, if you guys have any other questions, please let me know in the comments. And that's about it. Thanks for watching.